Hi, I'm Matt Powell. I'm the content strategist on the Web Services Developer Center on MSDN, and I'm here with
Richard Turner. I'm a program manager on the Indigo team that also owns our distributed application platform.
So we're here at TechEd today, and we want to talk a bit about service orientation. So Richard, why don't you let us know, what is this service orientation all about anyway?
Well, service orientation is a design philosophy and mindset that we're proposing people start thinking about and start adopting when constructing services and applications today and for especially moving forward into the future. This embodies the kind of things that we've been thinking about in terms of building component-oriented systems in the past, as well as taking what we've learned about building web-oriented systems moving forward.
So, we've heard here at TechEd quite a bit about the four tenets of service orientation, and you want to explain those for us?
Absolutely. If you were to go to Google today and you should do a search on service orientation, you'd end up with 30,000 odd hits from different parties, and no two parties would typically agree on what exactly service orientation is. So what we've done in our team is we've constructed our view of what service orientation is, and it's absolutely fundamental to what we do because we're building Indigo, our service-oriented platform and application infrastructure for the next generation web services. So what we wanted to do is provide a concrete definition that is very tangible and very available to people to help guide them into building service-oriented systems in the future. And essentially what we've done is we've summarized our thinking into four key tenets. These are essentially rules of thumb. They're not necessarily hard and fast rules in that if you do break a rule or you divert from a rule, then you have to understand what the implications are. But the four rules, essentially, or four tenets essentially are, one, that services have explicit boundaries. That services, the only way to interact with a service or to obtain information or modify the state of the service is via the technology exposed at its outer boundary edge. Tenet number two is that services are autonomous. And what this means is that if I was to build an application that consumed a service that was outside of my boundary of control, then I would not expect the service at the other end to implement its functionality in any particular way or manner. I wouldn't be able to influence it in any way. I won't be able to connect my SQL Server database directly to the SQL Server database or Oracle database or whichever inside the remote service. I'm simply talking to that service through its boundary, and it automatically enforces an isolation layer between our two services. This allows us then to construct very flexible, very decoupled applications. The third tenet is that services share schema and contract, not class, and more accurately, maybe not objects. Services are about passing information back and forth between two entities, such that those two entities can communicate in a common fashion. This is not about remoting an object that actually runs on a service remote from me and controlling it from my environment, because the other service may be running on a platform completely different to mine, and I may not have knowledge as to how to affect that component and how it runs in that environment. So services are all about passing information back and forth, passed by value, if you will, rather than by reference. The fourth tenet then is that services interoperate based on policy. And the policy can be information such as, for example, as a service, if you want to speak to me, you must support some kind of security mechanism, or you must support TCP as a transport protocol, or that you must support transactions, for example. Now, some of those capabilities are available today through things like COM+ or enterprise services, in that I can mark a component as requiring transactions, and if I state that transactions are required, you must interoperate with me using transactions fully supported through DT6. This isn't necessarily fully available through all technologies, however, and we're working to make this a reality in the near future.
Now, you mentioned that services are autonomous, they have explicit boundaries and so forth. Does that mean that once you're within that one service that there aren't other services around, or can they interact somehow? Or
very good question, and this is something we're very, very keen to help people understand, is that services are fractals to us. If you open up one service, you might find another 4 or 5 inside. If you open up any one of those services, you might find more services inside, and so on and so on and so on, until you get to the point where components make sense. where you're not going to expose any more functionality from that service atomically to the outside world. You're going to keep that inside your service, and that's really where components carry on and carry on their existing work today.
Yeah, so I can see there's a lot of agility in that, where you get those different services and you plug and play whatever you need to do for your particular business
Absolutely.
need.
The composability of service-oriented applications is absolutely crucial to building really dynamic, really decoupled applications that are far less fragile than the applications we build today.
So this is all great, and I love the idea of service orientation. Everybody across the industry, whether they kind of have figured out the four tenets or not, I think sees the power in the service-oriented idea. But you talked a lot about Indigo and so forth, and I know we have a ways for that. Do we have to wait until Indigo to do this, or can we use some of the technologies today as well?
Absolutely not. And this is a really, really important thing. You don't have to wait for Indigo to build service-oriented applications. You can build service-oriented applications today. You probably have been able to actually for some time. It may not just have been aware of the fact that you could, because our guidance wasn't necessarily published yet. But essentially you can go ahead and build service-oriented applications today. Let's just think about our four tenets. If we think about the first tenet, with services having explicit boundaries, technologies such as ASMX Web Services enable us to enforce a hard boundary around our service. If we provided them the only means through which you can communicate with my service is via ASMX as a web service technology, then that's the only way you're going to be able to interact with me. You won't be able to tunnel extraneous, miscellaneous protocols through my web services.
Sure, that whole loosely coupled idea really works perfectly in that type of scenario. How about for things like enterprise services or remoting?
Very good question. And enterprise services is a component-oriented technology. If you build enterprise service applications, you tend to find that they're very tightly coupled, and if you try and remove any one of those elements, they tend to be very fragile, and it's very difficult to change once deployed. So those technologies typically live inside the service boundary and implement the complex business logic with transactions spanning multiple objects and spanning multiple resources. And it's a very, very powerful technology to carry on building that kind of infrastructure.
Yeah, you mentioned earlier you're talking about COM+ and having the transaction information and so forth as kind of a policy issue there.
Yeah.
Can you actually do service-oriented programming with COM+?
You could, but one of the key things about service orientation is that if we're going to be building these services to be lightly coupled to each other, and we're all going to be able to interoperate with each other on the wire, then DCOM isn't necessarily the best protocol to use. It's very prevalent in the Windows environment, but it's not very prevalent in, for example, Unix and other environments.
Sure.
So we do suggest that wherever physically possible, and there are very few situations we've actually found where this isn't possible, that you expose your ASMX at the service boundary, web services at the service boundary. You can then take advantage of, for example, WYSI to enrich those web services to give you security and at least the basic implementation of policy today, as well as many other richer features, especially in terms of producing full duplex communications with web services, for example.
Right. And that's one of the things it's really not natural necessarily with our implementation on ASMX that you necessarily are really talking about wire-bound sending messages to and from, because you build a web method, you're making a procedure call, you on your client application, you import the thing, you've got this thing that looks like just a proxy object that you're calling, but in fact, that's really key, is that WSDL contract gives you that boundary interface, and that's why we can, for instance, interoperate with different platforms.
Absolutely, and this feeds very much into tenet number 3, which is services share schema and contract, not objects, back and forth on the wire. We're just passing data by contract back and forth. We're publishing the data contract in the WSDL. We're publishing the service contract in the WSDL as well, and it all becomes much easier to bind systems together much more loosely than we have in the past.
Right. That's why quite often on the Web Services Developer Center we're writing about being very aware of what you're doing within your code that's going to affect how the WSDL turns out and how you can implement with using various attributes and so forth to really mold that into just what you want it to do for the actual wire protocol stuff.
And if you're really into this propeller head kind of stuff, you could of course start with the WSDL first approach, where you write the WSDL and then generate the proxy for the client and the empty shell server classes, and then implement those on the server.
Yeah, and what I kind of tell people in general is that build the XML. The real place to start, build the XML on the wire, or to that you expect for your thing to look like. That'll enclose the data, take that, create a schema based off of that XML, take that schema, put it into, use the classes that will be created for that schema, and then put that into your web methods, and those are the things will work very nicely in that type of...
Absolutely, very good advice, especially if you're building really serious systems with this. The one thing I would like to mention is that the prescriptive guidance around remoting in particular has caused some consternation to some people. And we stood up at PDC actually when we first introduced Indigo last autumn, and we said that essentially remoting was not necessarily the right approach for building web services, certainly, and may not be the right approach for building component-oriented systems. And our recommendation for remoting is that it is a very interesting technology. It allows you to do some very interesting things from a technical perspective, but it has some primary goals some primary tasks that it's particularly well suited for. In particular, going cross-app domain inside the same process. That's really the only way to do this without hitting the network stack right now. And the other way, of course, the other thing that it's great for is for handling custom wire formats. Okay. If I wanted to be able to handle a custom wire formatted to a legacy mainframe, for example, and that was available via TCP, then I could use remoting to implement custom channel and sync to enable the custom wire formatting of our data going out across the wire and coming back.
Yeah. But otherwise, you don't get the normal the WSI basic profile compliant web services. There's really no reason to use that SOAP implementation, right?
Yeah. Using remoting in a SOAP type environment is not necessarily the optimal way of doing things from many, many perspectives. One of which is that remoting now uses a different SOAP encoding mechanism to the SOAP encoding mechanism that everyone seems to be going towards now. So you're limited also on interop on the wire. Other things like, for example, sheer practicalities. If I implement a remoting component, where do I host it? Yep. Either I host it inside IIS, or I have to write my own application, handle the threads, make it all reliable, resilient, manageable, deployable, and so on, which is a huge amount of overhead in terms of writing that infrastructure instead of writing your business logic. And the other thing, of course, is that remoting doesn't provide, at least out of the box, doesn't provide security on the wire. Whereas Enterprise Services does all of this for you, and its transport is faster than than remoting binary anyway.
Right. Well, speaking of performance, what sort of guidance should we use today about if we want to get good performance? You know, we have there's all kinds of talk about how there's this big overhead with XML serialization when you're using web services. Can we really afford to use that in a performance scenario?
That's a very good question. It's something we've been getting a lot of feedback over the last few days here at TechEd, and certainly over the last few months leading up to TechEd. And the general story is that if we were to treat our web services in a similar fashion to the way we treat our enterprise service components or COM+ components, and if we take our guidance on making method calls as physically busy as possible, making method calls very chunky rather than very lightweight and very chatty, the overall proportion of time spent making any given method call will largely be work rather than a small amount of transport. So adding a little more transport to something that's very work-oriented is not going to incur that much of a performance hit.
Right, and then on top of that, you get all the interoperability and the fact that your platform, independent.
Absolutely. Whereas, of course, if you don't take our guidance and your method call is largely transport with just a little amount of work, adding yet more transport is going to make your call even more expensive. And so if you haven't followed the guidance and you go ahead and implement very chatty web service interfaces, then yes, you will probably see a performance impact. But it may be sufficient for your needs.
Right. Well, what other information might we expect? Are we going to get some papers describing this on MSDN?
Yes, you will be getting some papers. We're actually having several written right now. We have papers being written about what is our prescriptive guidance, more detail around the information we've been discussing here. We have white papers coming out about how to make the existing technology really fly, how to really squeeze the best performance out of our existing infrastructure, and comparing, for example, ASMX, web services, remoting, and enterprise services in similar implementations in different scenarios. So we'll see papers like this coming out soon.
Well, that'll be really good. I think a lot of people will be very interested in seeing that.
Hopefully so.
Yep. Well, I guess that pretty much wraps up. And from TechEd, thanks a lot. We'll talk to you later.
Thank you very much.